Hello students, today we are going to do Lagrange's mean value theorem, which is second theorem after Rawls theorem. Rawls theorem we have discussed earlier, so now we are going to discuss Lagrange's mean value theorem. Now it is similar and different in many ways as compared to Rawls theorem. So let us consider the statement. Let f be a function defined over closed interval a comma b such that first point is like Rawls theorem, f is continuous in closed interval a comma b. Second is again like Rawls theorem, f is differentiable in open interval a comma b. And unlike Rawls theorem, there is no third condition that f of a is equal to f of b. There is no this third condition in LMVT or Lagrange's mean value theorem. So if two conditions are satisfied, then there exists at least one C belongs to open interval a comma b such that f dash c is equal to f of b minus f of a over b minus a. In Rawls theorem, it was f dash c is equal to 0, whereas here f dash c is not 0. This is equals to f of b minus f of a over b minus a. Students, one thing should be noticed here, that if I put third condition of Rawls theorem here, that if I make f of a is equal to f of b equal, f of a and f of b equal, then right hand side becomes 0. That means we can say that if third condition f of a is equal to f of b is added in this condition, this Rawls theorem, this LMVT, then it is converted into Rawls theorem. If f of a is equal to f of b, then right hand side is 0 and this LMVT is converted into Rawls theorem. So now, like Rawls theorem, it also has geometrical meaning. So what is this? Let us consider. Now suppose f of a is a function and is defined over closed interval a comma b. Now this I am highlighting, this is the graph of function f of a. At point A, as the coordinate of any point are x comma y, so value of x is a, and as y is equal to f of x, so value of y is f of a. Same with the point B, that x is b and y is f of b. So if I find the slope of line AB, then what is it? It is y2 minus y1 upon x2 minus x1, and from the graph I can see this is y2, this is y1, so y2 minus y1 over x2 minus x1. So this, that means right hand side of Rawls theorem, f dash c is equal to this, is actually representing a slope of chord AB. So this is actually representing slope of chord AB. Now what does f dash c represent? So it represents the slope of tangent at C. Now from this statement, what do we mean? We mean that slope of tangent at C is equal to slope of the chord AB. So sometime question can be asked like this. So sometime question can be asked, we will discuss it later on. So now let us consider one problem. Verify LMVT for fx is equal to x cube minus 2x square minus x plus 3 on closed interval 0, 1. Now as it is a polynomial function, so we can write, being a polynomial function, fx is continuous everywhere. Now let us check the second condition. Now f dash x is 3x square minus 4x minus 1, which clearly exists for all x belongs to open interval 0, 1. That means there is no point which is making this derivative not defined. That means fx is differentiable also in open interval 0, 1. Now f dash c is equal to f of b minus f of a over b minus 1. So f dash c is 3c square minus 4c minus 1, and f of 1 minus f of 0 is actually 1 minus 3 divided by 1 minus 0, which is 1. So thus we are left with a quadratic equation which can be easily factorized by middle term splitting, and we are getting two values. Actually we are getting two values, 1 and 1 by 3. Now 1 doesn't belong to open interval 0, 1, so it is rejected. So it doesn't matter if one value is rejected. Now one value 1 by 3, this belongs to 0, 1. So we can say theorem is verified. Now next question statement is very much interesting. Using LMVT, find a point on curve y is equal to under root x minus 2 defined in closed interval 2, 3 where the tangent is parallel to chord joining the end points. Now read the statement up to here. End points, that means 2 and 3. Sometime this interval is not given to you. In the question setter, they never tell you the interval, and they say ki find the point where tangent is parallel to chord joining the, instead of end points they say like this, joining the points 2, 0 and 3, 1. So from here we have to make the interval ourselves, like this is the value of x, so we have to make interval by close interval 2, 3. Only values of x will make the interval. So in our case actually it is given, so we are using the interval. Now as it is not a polynomial function, so I'll check the differentiability first. Now f of x is equal to under root x minus 2, f dash x is equal to 1 by 2 root x minus 2, which clearly exists for all x belongs to open interval 2, 3. Therefore we can say f is differentiable and hence continuous. This is very, very important. We have discussed this in Rawls theorem also, कि if we have checked the differentiability first, then we can declare the continuity also on the basis of this result, as every differentiable function is continuous. Remember this line we discussed in the Rawls theorem also. So hence all the conditions of LMVT are satisfied. Now again f dash c is equal to f of b minus f of a over b minus a. F dash c is 1 upon 2 root c minus 2. F of b is 1, f of a is 0 upon 3 minus 2. Rest is simple calculation, and from here we can say c is equal to 9 by 4, which actually belongs to 2, 3. But our question was not direct that find c. Our question was find a point on the curve where tangent is parallel to chord. So this c is our x coordinate. So putting x coordinate in y, so this is our y coordinate, which is half. So finally 9 by 4 half is a point where tangent is parallel to chord joining the end points on the curve. So that's all about Lagrange's mean value theorem. That's all for today. Have a nice day. Take care.